Hello students, welcome to the class. So in the previous class, we have finished with the MCQs on classification of elements and periodicity in the properties. Now we are going to start with the next topic, that is a very interesting and important topic, chemical bonding and molecular structure. So what we mean by a chemical bond? Yes, first we'll discuss about chemical bonding in the first part of this topic, and then we'll go for molecular structure. So what basically means chemical bond? Yeah, and why a bond has to be formed? Why there exists the bonds, right? How, and if there is existing of a bond, we'll see why it exists and then which are the different types. Okay. So when we talk about a chemical bonding or chemical bond, this was for the first time observed by two scientists, Kozel and Lewis. Yes, they were making a study of different elements, atoms of different elements, let me say. And they found that the interesting thing what they noted is that we have studied it in previous videos also. Noble gases, or what you say, noble gases, that is your group 17 elements. Sorry, group 18 elements, group 17 are your halogens. So noble gases, these noble gases, they were called so, or they were also called as inert gases. Why they were called as inert gases? The reason was because of their inert behavior, that is because of their stable behavior, right? So if you see why the stable behavior was being observed, so when they observed the electron, and that was all, chemical reactivity was all based on, in the classification of elements only we have seen, chemical reactivity was all based on what? It was based on the electronic configuration of valence shell. Yes, it is based on the electronic configuration of the valence shell. That is, when electrons are in the valence shell, outermost shell, what electrons are present? Based on those electrons, or based on that electronic configuration, the chemical reactivity is dependent. When the chemical reactivity of noble gases was studied, they found that the valence shell had NS2 NP6 configuration. This was the configuration of the valence shell, right? NS2 NP6. Okay, so they found that the outermost shell with the s orbital was completely filled. With the p orbital, it was also completely filled. Spin up, spin up, spin up, spin down, spin down, spin down. Yes, it was completely filled. Because of this completely filled orbitals, all the orbitals were completely filled. Therefore, it accounted for the stability. And when the electronic configuration of all the other elements other than noble gases was studied, they found that all the other elements were not having completely filled configuration. They were not having completely filled configuration. Therefore, they were not stable. Yes, they were not stable. And anything in this universe, if you see, it tries to attain stability, right? It tries to become stable. Now the question is, how all the elements try to become stable? They tried to get such configuration in their valence shell, because inner core shells were all completely filled. So all the other elements, somehow they tried to get this configuration in their outermost shell. And when they were trying to get that configuration, there was formation of a chemical bond. Right? So chemical bond, it is defined as the attractive forces which hold the various constituents, atoms, ions, together in chemical species. Bond forms to get the stability with a release of energy. Whatever is getting stable, please do remember, students, when things are getting stable means it will be at low energy. Anything which, if it wants to become stable, it will come to lower energy. You just imagine, suppose you yourself, you consider your feelings. If you are too very happy, are you stable? No, we are not stable, because energy is very high. We are very excited. So when we come back to our normal energy level, we become stable. If we are too sad, we are crying loudly, we are very much upset, energy is very high. we are not stable at that state. Again, we come back to our normal ground state energy that makes us stable. Understanding? So even in the cases of chemical atoms and molecules, they try to get stable by lowering of the energy. That means if they have to come to lower ground energy, there must be release of energy. So wherever there is release of energy, it attains stability. So this is the consideration. So we say atoms are usually not capable of free existence. They do not exist freely except our noble gases. Except our noble gases. So what do atoms do? To become stable, they try to combine together. So this is the difference between atoms and molecules. Molecules exist independently. Molecules exist independently. Whereas atoms, they cannot exist independently except noble gases. So atoms try to combine with other atoms to become stable with the release of energy. Okay, so a group of atoms existing together as one species and having characteristic properties, they are called what? They are called molecules. Yes, so there must be some forces which holds the atoms together within the molecules, and those forces we call them as a chemical bond. What is a chemical bond? It is the attractive forces which holds the atoms or ions together in different chemical species. Okay, Causal-Lewis approach to chemical bonding. Now the question, this Causal-Lewis approach tells us, why do atoms combine? Why do atoms combine? So Causal-Lewis approach tells us why atoms combine. So according to this theory, atoms take part in the formation of their complete octet or to acquire electronic configuration of nearest noble gas atoms. And that can be achieved by gaining, losing, or sharing electrons. So atoms of different elements. Yes, atoms of different. Why do atoms combine? Yes, why do atoms combine? Atoms of different elements. Atoms of different elements. What happens? These atoms of different elements, they combine with each other. Why do they combine? In order to have completely filled configuration. Configuration in their outermost shell, in valence shell. Yes, so in valence shell, they try to have completely filled configuration. Therefore, atoms combine. Atoms combine. They combine with each other. Now, how do they combine and when do they combine? That depends. Yes, so they try to have completely filled configuration in the valence shell, just like the noble gases. And here, if you see the noble gases, they have got completely filled configuration with how many electrons? 6 plus 2, 8 electrons in valence shell. 8 electrons in valence shell. And this completely filled configuration with 8 electrons in valence shell is called octet rule. Is called octet configuration. What it is called? Octet configuration. So they try to have 8 electrons in the outermost shell. So that configuration is called what? It is called octet configuration. So somehow they try to have 8 electrons in the outermost shell, and that is called as octet configuration. Now let us define what is octet configuration. So what do we mean by octet configuration? Having 8 electrons in their valence shell. So all the atoms of different elements, they combine with each other to have 8 electrons in their valence shell, to have complete configuration of octet configuration, to have complete stable configuration with 8 electrons in their valence shell, either by losing the electrons or by gaining the electrons or by mutual sharing the electrons. Yes, so anyhow, somehow they try to have 8 electrons in the outermost shell, and this rule is called what? It is called octet rule. It is called octet rule. So what do we mean by octet rule? Atoms of different elements tend to combine to have 8 electrons in their valence shell, 8 electrons, stable configuration in their valence shell, either by losing electrons or by gaining electrons or by sharing electrons. This configuration, this rule is called what? It is called octet rule. It is called octet rule. So all the atoms try to have, if octet configuration, they try to have octet configuration. So atoms take part in the bond formation to complete their octet or to acquire electronic configuration of nearest noble gas atoms. It is called what? Octet rule. This can be achieved by gaining, losing, or sharing of the electrons. So the atoms of the elements tend to undergo chemical changes that help to leave their atoms with 8 outer shell electrons. Chemically active elements do not have an octet of electrons in the valence shell of their atoms. Octet of electrons means what? 8 electrons. Their reactivity arises from their tendency to achieve the octet. So reactivity, chemical reactivity arises in order to become stable, in order to have 8 electrons in the outermost shell, forming bonds either with atoms of their own types or with atoms of other elements. Therefore, its role can be appreciated. So those atoms, they may combine with their own types. That means similar atoms may combine, or the atoms may combine with atoms of other elements. Yes. So octet rule. Atoms of different elements take part in a chemical combination in order to complete their octet or to attain the noble gas configuration. This is called octet rule. This is called octet rule. Yes. Valence electrons. It is the outermost shell electron which takes part in chemical combination. And everything, every chemical reactivity, entire chemical reactivity of an atom is because of which electrons? It is because of valence electrons. Now I cannot say for all the elements try to have 8 electrons only. There are some cases like hydrogen, lithium, beryllium. Yes, if you see, hydrogen atomic number is 1, lithium is 3, beryllium is 4. If you see the configuration, it is 1s1, this is 1s2, 2s1, this is 1s2, 2s2. Correct. So for such elements, I cannot expect these elements to have 8 electrons. Just like we're expecting the baby to be strong, or expecting like how we eat two chapatis, I cannot expect a baby to eat two chapatis and become strong. Yes, depending upon its capacity, it can have food, right? Similarly, depending upon these elements' capacity, it is having S shell, so it cannot have maximum 8 electrons. So here hydrogen can have maximum of 2 electrons to become stable. Lithium also can have 2 electrons to become stable, same as in case of beryllium. So it is having 2 electrons. Such configuration for such elements, I cannot call it octet, I call it duplet. 2 electrons. I call it what? Duplet, having 2 electrons in the outermost shell. So atoms of different elements, they combine with each other in order to complete their respective octets, that is 8 electrons in their outermost shell, or duplet, that is 2 electrons in the outermost shell in case of hydrogen, lithium, beryllium, and so on, to attain the nearest noble gas configuration. To attain the nearest noble gas configuration. Okay. Now, modes of chemical combination. How we can expect? See, whenever chemical bonding is taking place, please do remember, when they are having octet configuration, trying to have octet configuration, they will try to achieve stable configuration. Stable configuration. Yes. So when they are when the atoms are combining, the atoms may be of same element or they may be of different element. When the atoms are combining, why they are combining? In order to attain stable octet configuration, or you can say duplet configuration. When they are trying to combine to have stable octet configuration, so what a molecule is formed, it will have stable, it will be stable. Yes, the molecule will be stable and it can exist independently. This molecule, when you compare the energy with the individual atoms, the energy of the molecule will be low. Yes, because when atoms combine, there is release of energy. There is release of energy. So molecule will have lower energy. Lower energy, I'll write it, lower energy accounts for stability. Lower energy accounts for stability. Please do remember this. Okay. So chemical bonding takes place to acquire a state of minimum energy. To acquire a state of minimum energy and therefore maximum stability. Maximum stability. So minimum energy and maximum stability to convert what? To convert atoms into molecules. To convert atoms into molecules. And we can divide these atoms into three. Say electropositive atoms we have. So electropositive atoms means what? They tend to lose electrons, right? So electropositive elements, the atoms of electropositive elements, they give up one or more electrons. They give one or more electrons, correct? Easily. Therefore, when I am saying they are giving one or more electrons easily, they have low ionization energy, correct? They have low ionization energy. Second point, electronegative elements. They tend to gain electrons. So when I say they tend to gain electrons, that means so they will gain one or more electrons. So when I say they are gain electrons easily, they have high negative value of what? Electron gain enthalpy. They have very high negative value of electron gain enthalpy. So one atom should have low ionization energy, another should have high negative value of electron gain enthalpy. So elements which have little tendency to lose or gain electrons also combine. Not only which give electrons very easily, which take electrons very easily, but elements, so this is first case, this is second case, third case, and elements which have little tendency to give or more take electrons also combine. So first case I can say which lose electrons means they are metals, and which gain electrons means they are non-metals. So such atoms may also combine. Sometimes the same atoms may combine. Same atoms may combine. Yes. Hydrogen molecule. It is formed by two atoms of hydrogen. Sometimes when metallic atoms combine, there is we cannot expect more difference in their electronegativity, right? So these all cases can be seen when atoms are combining. All these cases can be observed. Okay. Facts stated by Causal in the relation to chemical bonding. Okay, what did he say? In the periodic table, the highly electronegative halogens and highly electropositive alkali metals are separated by what? Noble gases. So after group 17, halogens. After halogens, we have noble gases. After noble gases, this side we have alkali metals. So highly reactive noble halogens and highly reactive alkali metals, they are separated by what? Noble gases. Okay. Formation of an anion and cation by the halogens and alkali metals. We know halogens form anions and alkali metals form cations, are formed by gain of electrons and loss of electrons respectively. Anion is formed by gain of electrons, cation is formed by loss of electrons. Anions are formed in case of halogens, cations are formed in case of alkali metals. Both the negative and positive ions acquire noble gas configuration. So by losing one or more electrons or by gaining one or more electrons, these anions and cations, they acquire what? Noble gas configuration. And we have seen in the previous class. Once they get the stable noble gas configuration with 8 electrons in the outermost shell, removing the electron from such an ion or adding an electron to such ion becomes very difficult. Yes, becomes very difficult. The negative and positive ions are stabilized by electrostatic attractions. We know unlike charges attract. So when such negative and positive ions come together, there will be attraction, and that is being stabilized by electrostatic attraction. Example. Sodium. Yes, we'll take it here. What is the atomic number of sodium? 11. Let me take a chlorine. Atomic number of chlorine is 17. Okay. Sodium 1s2, 2s2, 2p6, 3s1. So 2 electrons, then 8 electrons, and then 1 electron. Here 1s2, 2s2, 2p6, 3s2, 3p5. Correct? 2, 8, and 7 electrons in its outermost shell. Okay. So sodium is a atom of metal. So sodium tends to lose electron. So sodium, let me say it loses one electron. When sodium loses one electron, it becomes what? It becomes Na plus. When it becomes Na plus, that is our cation, it will have what configuration? 2 and 8, correct? Now this one electron is being gained by chlorine. Now tell me why sodium loses one electron? Because when sodium loses this one electron, it has the tendency to lose electron only. When it loses its one electron, it becomes this unipositive ion. And as soon as it becomes this ion, it becomes very stable. Why? It is having 8 electrons in its outermost shell. So it has completed. So I can say it has completed its octet. Therefore, it becomes a stable ion. Chlorine, it wants only one electron. I cannot say chlorine loses electrons, right? It is having high electron gain enthalpy because of its smaller atomic size. So it just needs one electron to have complete octet in its outermost configuration. Therefore, this electron which is lost by sodium, it will be gained by, so it will gain one electron by chlorine. So when chlorine gains one electron, it becomes Cl minus, that is an ion. And what will be the configuration? 2, 8, 8. So you can see there is a cation and an anion. So when sodium is losing electron, what have to be done? Energy has to be supplied to sodium. What is that energy called? Ionization energy. Then only electron will be lost. And chlorine, it has got very high negative value of electron gain enthalpy. Therefore, it will gain the electron very easily. And when it is gaining the electron, energy is released. Energy is released. Correct? Okay, so it will have configuration. And these two ions, positive and negatively charged ions, there will be electrostatic attraction. Correct? Unlike charges, they attract each other. So they immediately attract each other and they form NaCl. Yes, so there will be a bond between Na and Cl. Yes, understanding. So when they combine together, there will be release of energy. There will be release of energy. Yes, because they are combining in a very vigorous manner. There is a long electrostatic attraction. So as soon as they combine, there will be release of energy. There will be release of energy. Getting it? So energy gets released and a bond is formed. Whenever we speak about bond, we speak about 2 electrons. There will be 2 electrons involved. Understanding? So a bond is formed. Okay, I can show you all here in a different manner this concept. Yes, have a look. Sodium. Okay, sodium, it is having 11 electrons. So sodium will gain energy and lose its electron, becomes Na plus. Did you observe? Observe in the first case. So sodium, it is having 11 electrons. It will lose an electron and becomes, it will gain energy. I'm sorry, let me see it once again. Okay, sodium. So energy is taken, electron is given out. That electron is taken by chlorine and chlorine has released energy. You could have seen the arrow mark. Chlorine took up that electron, formed Cl minus ion and energy is given out. 2 of them are combining with the release of energy and formation of NaCl. Understood? Cl. So sodium has lost its electron. Chlorine has taken the electron from sodium. So sodium, when energy is given, it gives out its electron and becomes Na plus. Chlorine takes that electron, becomes Cl minus and energy is released. 2 of them, electrostatic force of attraction, they combine together to form NaCl. Can you see? Yes, both are having octet configuration. Both are having octet configuration. Understanding? Yes, energy is released. Energy is released. Is that right? Yes or no? Same thing we discussed. Energy is released. So there is release of energy. So depending, so what is happening? There is complete transfer of electrons. There is complete transfer of electron. So see here, Na has lost its electron. Cl will take that electron and become the nearest noble gas configuration. These 2 ions combine with the release of energy to form NaCl molecule. To form NaCl molecule. Such bond So modes of combinations by transfer of electrons. Just now what we saw is by transfer. So chemical bond which is formed by complete transfer of one or more electrons from one atom to another is termed as electrovalent or ionic bond. Just now what we saw was transfer of electrons. Sodium was giving its electron and chlorine was taking the electron, right? Second, it is also by sharing of the electrons. The bond which is formed by equal sharing of the electrons between one or two atoms is called covalent bond. In these bonds, electrons are contributed by both. Coordinate bond. When the electrons are contributed by one atom and shared by both, the bond formed is known as coordinate bond. So we'll discuss all these three bonds one by one. So ionic or electrovalent bond is formed by complete transfer of electrons from one atom to another. So when a bond is formed by complete transfer of electrons, when a bond is formed by complete transfer of electrons from one atom to another, why there is complete transfer of electrons? So as to complete their outermost orbits having 8 electrons, that is octet, or sometimes 2 electrons, that is duplet, and hence to acquire the stable nearest noble gas configuration, the bond formed is known as ionic or electrovalent bond. So this bond, what you are seeing, I call it as ionic or electrovalent bond. Yes, ionic bond. Let us first define it as ionic bond. Okay, explanation now. Let me say I have two atoms, A and B. And we know that from all the last videos, whatever we have discussed, we know that atoms are electrically neutral. So what are atoms? They're electrically neutral. Correct. So these atoms are electrically neutral. So what does this mean? They have equal number of protons and electrons. Correct? Okay. If suppose this atom A is going to lose electron, it will have more number of protons and it will form a cation. If atom B is going to gain electron, it will have more number of electrons and it will going to form an anion. Correct? So on losing an electron, an atom becomes positively charged, since now the number of protons will be more than number of electrons. So atom A, it will lose one electron and form plus ion. So one electron is lost and I call it as cation. On the other hand, in case of other atom B, gaining of the electrons, the number of electrons exceed the number of protons. Thus, the atom becomes negatively charged. So, this atom B will gain this electron, which is given by A, and becomes B minus. That is, anion is formed. Okay, anion is formed. The oppositely charged ions, charged particles formed here, A plus and B minus, there is electrostatic forces of attraction. So, they attract each other by electrostatic forces of attraction. And the bond formed, so A plus plus B minus, electrostatic force of attraction, there is AB molecule, and this is the bond. Yes, with the release of energy, okay, and this bond is called what? It is called ionic bond. It is called as ionic bond. Is that clear? Yes. So this is how an ionic bond is formed. An ionic bond is formed. Is that understood? Okay. So let us see what is explanation given here. Generally, it is formed between metals and non-metals. We'll see the factors, that time we'll come to it. We can say that it is the electrostatic force of attraction which holds oppositely charged ions together. The compounds which is formed by ionic or electrovalent bond are known as ionic compounds or electrovalent compounds. You can see here. NaCl is an ionic compound, or it is also called electrovalent compound. Formation of NaCl is given. So Na, I can show it here. Atomic number is 11. So here there are 2 electrons, and here, let me say this is inner shell, 1, 2, 3, 4, 5, 6, 7, 8. Okay. Okay, so here there is one electron in the outermost shell. So what sodium does, it will lose some ionization energy is given. It will lose that electron. It will lose that electron. To whom it will lose? Chlorine is having 7 electrons in its outermost shell. Here 1, 2, 3, 4, 5, 6, 7, 8, and here 2 electrons. And outermost shell there are 7 electrons. Okay, so it will, sodium will lose its electron, and that electron is being taken up by whom? It is being taken up by chlorine. So can I say there is a complete transfer? There is complete transfer of electrons from one atom to other atom. From one atom to other atom. Yes. So what happens? Na after losing the electron becomes Na plus. Cl after gaining electron becomes Cl minus. You can see this electron is being gained by Cl, and there is electrostatic force of attraction which makes it come together and form NaCl. Yes, NaCl. And this bond is called what? It is called ionic bond. And this whole compound as a whole is called ionic compound. Why it is called ionic compound? Because there is electrostatic force of attraction between the charged ions, positively and negatively charged ions. When you're writing it in compound form, you need not show these charges. So it is attraction between the ions, therefore it is called ionic bond. Yes, it is called ionic bond. Is that clear? Can you see here? So this is the formation. We have many other examples also. The other examples include, let me say I have a compound that is magnesium oxide. Okay, this is magnesium oxide. Let me consider Mg, atomic number 12, oxygen, atomic number 8. So shall I write the configuration? It is 1s2, 2s2, 2p6, 3s2. So it is 2, 8 and 2, correct? Oxygen 1s2, 2s2, 2p4, 2 and 6. Now see, unlike the other compound what we discussed, magnesium, if it has to attain octet configuration, it has to lose how many electrons? Magnesium has to lose 2 electrons, correct? So when magnesium loses 2 electrons, it becomes what? It becomes Mg plus 2. And the configuration is 2, 8. Is that right? After losing 2 electrons, it gets octet configuration. Oxygen, on the other hand, to have octet configuration, it needs how many electrons? It needs 2 electrons. Therefore, the 2 electrons which are given by magnesium are being gained by oxygen, correct? So oxygen gains 2 electrons. It gains 2 electrons and becomes what? O minus 2, or 2 minus also you can write. Okay, so it becomes 2, 8. So both the atoms are now having octet configuration. They become stable. I'm sorry, both the ions, they are not atoms now. These two are neutral atoms. They are not now having octet configuration and they have become stable. Since both are oppositely charged ions, there will be electrostatic forces of attraction. And these two oppositely charged ions come together to form a bond and combine, form a molecule. That is compound, right? So it forms magnesium oxide compound as we have seen here. Is that right? So this is another example. Let me take one more example. Sodium oxide. Okay, see here. Sodium atomic number 11, 2, 8, 1. Oxygen atomic numbers 8, 2, 6. Now sodium can lose how many electrons to have octet configuration? Sodium can lose only 1 electron. Therefore, to form Na plus. When it forms Na plus, it will have octet configuration, becomes stable. But oxygen, if it has to be stable, it has to gain how many electrons? It has to gain 2 electrons, right? And become O minus 2 with octet configuration. So if oxygen has to gain 2 electrons, those are gained by sodium only in this compound formation, right? But sodium is giving only how many electrons? Only 1 electron at a time. Oxygen needs how many electrons? 2 electrons. Therefore, what I will do? I will take 2 sodium atoms. So this sodium atom also will lose 1 electron and form Na plus with configuration 2, 8. Correct? So there are how many electrons lost now? There are 2 electrons lost by 2 sodium atoms. And those 2 electrons will be gained by whom? They will be gained by oxygen. So there is electrostatic force of attraction between these 2 ions and these 2 ions. This oxygen ion. So sodium, how many atoms have taken? 2. So there are 2 ions, and oxygen there is only 1. Understanding? So this is how a compound will be formed. Ionic compound is formed. Yes. Similarly, you can quote explanation for calcium fluoride, CaF2. Yes. Calcium atomic number 20. So what will be the configuration? It is 2, 8, 8, 2. You can write it and see. Fluorine, it is 9, 2, 7. So calcium can lose how many electrons to form octet configuration? So calcium loses 2 electrons, because when it loses 2 electrons, it will have octet configuration in its outermost shell. So it will form Ca plus 2, right? So 2, 8, 8. Ca plus 2. But fluorine needs how many electrons? It wants only 1 electron to become octet. Correct? So to become F minus. So 2, 8. It becomes completely full. But here calcium is losing how many? Calcium is losing 2 electrons. And each fluorine atom needs only 1 electron to become octet. Therefore, there comes one more fluorine atom, 2, 7. So it will also gain 1 electron to form F minus with 2, 8 configuration. Yes or no? So calcium loses 2 electrons, which are being gained by 2 fluorine atoms. And there is electrostatic force of attraction between all of them. So there is calcium 1 ion, fluorine 2 ions. So the formula of the molecule will be CaF2. CaF2. So I have explained examples including all the types of molecules. Yes, formation of magnesium oxide. See here. 2 electrons are being completely transferred from magnesium to oxygen, Mg plus 2, O minus 2. Electrostatic force of attraction, it forms MgO. Now, why ionic bond is also called as electrovalent bond? During the formation of ionic compound, see, when ionic compound is formed, suppose it is formed between Na and Cl. Sodium loses 1 electron, chlorine gains 1 electron. Yes. So whenever ionic compound is formed, electrons are being lost by one atom and gained by other. Correct? Now, the loss of the number of electrons or the gain of the number of electrons, or you can say the number of electrons lost or the number of electrons gained during ionic bond formation is called electrovalency. What it is called? Electrovalency. So how do we define electrovalency? It is the number of electrons lost or number of electrons gained during the formation of an ionic bond. Therefore, ionic bond is also called electrovalent bond. For example, in formation of NaCl, Na is going to lose 1 electron. Yes, therefore, electrovalency of sodium is +1. Loss means plus. Electrovalency of chlorine is -1. So, number of electrons lost or number of electrons gained during ionic bond formation is called electrovalency. So we took the example of sodium chloride. Sodium loses 1 electron. Loses, so plus charge. Chlorine gains 1 electron, so minus charge. So electrovalency of sodium is what? It is +1. Electrovalency of chlorine is what? It is -1. If I consider the example of sodium oxide, yes, so sodium loses how many electrons? It again loses 1 electron only, because there is only 1 electron to be lost by each sodium atom. Correct? So I cannot say 2. I am speaking about only 1 atom. Oxygen gains how many electrons? Oxygen gains 2 electrons. Therefore, what is the electrovalency of sodium in sodium oxide? It is still 1. Sorry, +1. Correct? What is the electrovalency of oxygen? It is -2. Understanding? So oxygen gains 2 electrons. So -2. Similarly, magnesium oxide. Magnesium loses 2 electrons. Oxygen gains 2 electrons. Therefore, electrovalency of magnesium is what? It is +2. Electrovalency of oxygen is what? It is -2. If I give you one more example, calcium fluoride, CaF2, we have discussed calcium loses 2 electrons, but fluorine can gain only 1 electron. Therefore, electrovalency of calcium is what? Calcium is +2. Electrovalency of fluorine is what? It is -1. If you consider Na2S, sodium sulfide, Looking at the formula only, you can say sodium can lose 1 electron only, so it is +1. Sulfur gains 2 electrons, so it is -2. So electrovalency of sodium is what? It is +1. Electrovalency of sulfur is what? It is -2. Understanding? So electrovalency means what? It is during the ionic bond formation. During the ionic bond formation, the number of electrons lost or the number of electrons gained, the number of electrons lost or the number of electrons gained is called as electrovalency. So sodium and calcium, they have, if you take example, they will lose electrons. So the electrovalencies are +1 and +2 and so on. Calcium, oxygens and chlorine and all, if you see, they will gain electrons and their electrovalencies will be minus. And therefore, the ionic bond is also called as electrovalent bond. Factors affecting the formation of ionic bond. What are the factors which affects the formation? That means if suppose I say I have two ionic compounds, which is most ionic, if you want to compare like that time we need to understand the factors which affect the ionic bond formation. Okay. First factor is ionization enthalpy. As we know that ionization enthalpy of an element is what? It is the amount of energy required to remove an electron from outermost shell of an isolated gaseous atom to convert it into cation. Okay. Now, what role has ionization enthalpy to play in ionic bond formation? Let me say I have two atoms. This is the atom which is going to combine, and here I have one more atom. Okay, so these are the two atoms. So this is atom A and this is atom B. Yes. Okay. Now, one atom should have, according to the factors, one atom should have very low ionization energy. Why is it so? See, when we speak about the atoms, the atom which changes into cation, it will be having 1, 2 or 3 electrons in its outermost shell, correct? Okay. And the other atom which changes into, so let me say this is going to change into cation and this is going to change into anion. Why I have written so also I will tell you. I could have written here anion, here cation, but I have not written it. So the atom which changes into cation, it will have 1, 2 or 3 electrons in its valence shell. It will have 1, 2 or 3 valence electrons. And the atom which is going to form an anion, it will have 5, 6, 7 valence electrons because it will take. Okay. Now, if you see, when I speak about ionization energy of one atom should have very low ionization energy, I'm saying. Now, what is ionization energy? The energy required to remove an electron. Yes. So, only when one atom loses electron, the other atom will gain electron. So, this should lose electron. Okay. Now, if I say just for an atom to lose electron, will it lose electron? No. I have to put some energy to this electron. Then only this electron will be lost. And that energy is called ionization energy. Ionization energy is very low. Means what? That means to remove this electron, I need very less amount of energy. If I supply very low amount of energy also, this electron will be lost. Yes or no? So, the ion which is going to form cation, the atom which is going to form cation, the atom which is going to lose electron should have very low ionization energy. Why? Because lesser the ionization energy, easier will be the removal of electron. Yes or no? Easier will be removal of electron. Are you all understanding? Easier will be the removal of electron. So, ionization energy of one atom which is going to lose electron will be very less. Yes, so lesser the ionization energy, easier will be the removal of electron, that is formation of positive ion. Hence, greater will be the chances of, therefore, I can say greater will be chances of formation of ionic bond. Correct or no? Ionic bond. Yes, compare. If one atom is going to is having very low ionization energy, another atom is having very high ionization energy. Let me say there is one more atom. Yes, it is so much big. So it is having high ionization energy. High ionization energy. So where electron, which atom will lose electron very easily? This will lose electron very easily. to this atom. So here the chances of ionic bond formation is more. Therefore, I will say this will be more ionic than this. Understanding? That will be more ionic than that. Understanding? So this is how first factor comes into context, that is ionization energy. Ionization energy should be least for the one of the combining atom which is going to lose electrons. Second factor is electron gain enthalpy. Now see, this atom is going to gain electron to form anion, correct? It is going to gain electron to form anion. So if this atom is going to gain electron very easily, what happens? There will be release of energy, correct? But if this atom will not gain the electron easily, what will happen? We need to put energy on the electron to make it gain. So in which case, the ionic bond formed will be very easy when atom gains the electron very easily with the release of energy. Understanding? So for the atom which is going to form anion, it should have very high negative value of electron gain enthalpy. That means it will gain the electron very easily. Because we know electron gain enthalpy, or you can call it as electron affinity also. It is what? It is the enthalpy change that takes place when an extra electron is added to the isolated atom. Yes. So higher the electron gain enthalpy, imagine that it is, I'm speaking about higher the negative value of electron gain enthalpy. What we say? More is the energy released. More is the energy released. Yes. And more stable will be ion formed. Yes or no? More stable will be ion formed. Yes. So consequently, probability of formation of the ionic bond will be more. Yes. So halogens, if you see, example, they have got very high halogens, they have got very high electron gain enthalpy. On the other hand, alkali metals have got very high tendency, very low ionization energy to lose the electrons. Understanding? Are you all getting? Therefore, we say, so formation of negative ion is more common in case of halogens. That too, which halogen? Where electron gain enthalpy is highest for which halogen? Is it fluorine or chlorine? It is for chlorine. Yes. So it will be large amount of energy will be released. So electron gain enthalpy is highly negative. So first two factors. One of the combining atom which is going to lose electron, it should have least ionization energy. Because lesser the ionization energy, easier will be the removal of electron and greater will be the chances of formation of ionic bond. Second, the other combining atom which is going to gain electron should have very high electron gain enthalpy, because higher the electron gain enthalpy, that is more negative the electron gain enthalpy, more is the energy released and more stable will be the ion formed. Yes. So this will lose the electron very easily and this will gain the electron very easily if these two conditions are followed, and more stable, very fast the ionic compound will be formed. Now my question, a small question to you all. Let me see. Suppose there is a bond formed between lithium and fluoride. So lithium fluoride is an ionic compound. One more is sodium fluoride. Which is more ionic? How do you say? Yes, in this case, anion is same. So when anion is same, I will not worry about electron gain enthalpy, correct? But cations are different. Cations are different. So when cations are different, I have to think about ionization energy of lithium and ionization energy of sodium. How are they present? One below the other. As you move down the group, ionization energy decreases because atomic size increases. So which is having least ionization energy? Sodium. So ionization energy of sodium, ionization energy of lithium is more than ionization energy of sodium. Yes or no? So which bond will be formed more easily? Sodium fluoride is more stable ionic compound than lithium fluoride. Understood? Understood the reason? Getting my point? Understanding? Okay. On the other hand, if I give sodium fluoride and magnesium fluoride, sodium fluoride, magnesium, this is across the period. We know across, again, it is a cation only what we are going to consider. Across the period, atomic size decreases, therefore ionization energy increases. So this is going to have low ionization energy. Again, sodium fluoride will be more stable ionic compound than magnesium fluoride. What if I give you like this? Sodium fluoride and sodium chloride. So which is more ionic? Now here we speak about anions. We speak about anions and we speak about electron gain enthalpy. Where more amount of energy is released? In case of chlorine. Therefore, sodium chloride is more ionic than sodium fluoride. Understanding? So with those two factors, that is very least ionization energy for cation and very high electron gain enthalpy for anion, we can explain which is the more stable ionic compound. Which is the more stable ionic compound. So lesser the ionization energy, easier will be the formation of cation and have greater chance to form the ionic bond. Due to this reason, alkali metals have more tendency to form ionic bond. Yes, just now I said, okay, before that we'll discuss both the points and then I will explain. In formation of Na plus ion, ionization energy is 496 kilojoules. That much energy is required to lose the electron. In case of magnesium, it is 743. So where electron will be lost very easily? In case of sodium. That's why formation of positive ion for sodium is easier than that of formation of magnesium ion. Therefore, we can conclude that lower the ionization energy, greater the chances of formation of ionic bond. Greater the chances of formation of ionic bond. Right? Next, second concept is electron gain enthalpy or electron affinities. It is defined as the energy released when an isolated gaseous atom takes up an electron to form anion. So greater the negative charge, greater the negative electron gain enthalpy, easier will be the formation of anion. So consequently, probability of formation of ionic bond increases. Halogens possess highest electron gain enthalpy, which is also called electron affinity. So formation of anion is very common in halogens. That to which halogen? Chlorine. Minus 348 kilojoules. That means this much kilojoules of energy is released when an electron is gained by chlorine atom. So it is negative. So now here with these two explanations, I can say one atom has to lose electron very easily. Another atom has to gain electron very easily. So the atoms of which elements are lost very easily? It is of metals. Because metals are electropositive. They tend to lose electrons very easily with least ionization energy. And which atoms gain electron very easily? They are non-metals. Because they are electronegative, they have very high electron gain enthalpy. So the ionic bond is basically formed between what? The ionic bond is formed between metals and non-metals. That's the reason when I was explaining in one of the point, I said I will tell you later what does that mean. So ionic bond is formed between metals and non-metals. It is formed between metals and non-metals. Okay. Third concept is lattice energy or lattice enthalpy. Now, what is lattice energy? It is defined as the amount of energy required to separate 1 mole of ionic compound into separate oppositely charged ions. Now, you can see here, see, I told you, when an ionic compound is formed, suppose Na plus combines with Cl minus and forms NaCl. Yes, suppose I take 1 mole of NaCl. 1 mole of NaCl. Okay, so these 1 mole of NaCl, whenever NaCl is formed, ions come closer and form NaCl compound. Yes, this is NaCl. So this is Na, this is Cl, this is Na, this is Cl. So what it forms is, it forms a structure, and that structure we call it as lattice structure. What we call it as? We call it as lattice structure. Understanding? So you understood what is lattice structure? It is called lattice structure. Okay. Fine. So it is lattice. This structure, what you're seeing, when ions combine, they form lattice. They form lattice. Okay. So when this lattice is formed, let me say it is of 1 mole of NaCl. So lattice contains 1 mole of NaCl. Now, when I want to break this lattice, what happens? Na plus ions come out, Cl minus ions come out. Yes or no? So I cannot say I will just break. If I want to break anything, I need to put energy. So what energy I am going to put? The energy what I am going to put to break this lattice into what? Into constituent ions. I am going to separate them into ions. So what energy is required? The energy is required to separate 1 mole of ionic compound into constituent ions. When I want to separate them into constituent ions, that energy is called lattice energy. What it is called? Lattice energy. Yes, it is called as lattice energy. So when I want to separate the lattice, when I want to break the lattice, the energy required to break the lattice is called lattice energy. So I can say lattice energy is what? Lattice energy, it is the measure of strength of the bonds. Yes or no? If this bond is very strong in this lattice, I will need more energy. If the bond is weak, I will need less energy. So it is what? It is the strength of ionic bond, measure of strength of ionic bond. It provides the insight into several properties of ionic compounds, say solubility, volatility, hardness. If lattice energy is more means what? That means it is very hard. If lattice energy is more means what? That means I need to put more energy to break it into from solid to liquid state. So solubility, melting point and high boiling point. If lattice energy is more means what? If I dissolve such compound in water, I need more attractive forces to convert it into ions, to break it into ions in the water. Yes, so lattice energy of ionic solid, it cannot be measured directly. This has to be measured or estimated with the help of one cycle, and that is called Born-Haber cycle. It is called Born-Haber cycle. It cannot be measured directly. And this lattice energy, same as energy factor, it is expressed in kilojoules per mole. What does that mean? How much kilojoules? For example, if I say lattice energy of NaCl is minus 787 kilojoules per mole. What does that mean? It means 787 kilojoules of energy is required to break this lattice into constituent ions. Or if I say to form these ions, when Na and Cl combine, I said no, Na plus and Cl minus, they combine and there will be release of energy. I had shown you in one of my animation what I had created. Yes, do you remember? Can you see here? So Na will lose electron by gaining energy and form Na plus. Cl will gain electron, it will give out energy. When they both are combining, there is release of energy. Can you see this? There is release of energy. Understanding? So when these ions combine, what will happen? When Na plus and Cl minus ions combine, there is release of energy. How much energy? Minus 787 kilojoules per mole. It is nothing but lattice energy only. So when ions combine to form a lattice, 787 kilojoules of energy is required. 787 kilojoules of energy, when ions combine to form a lattice, 787 kilojoules of energy is released. The question can be asked like this. So much energy is released. What is the lattice energy of the compound? So what will be the lattice energy? Lattice energy means what? Energy required to break the lattice. If this much energy is released when these are combining, then the same amount of energy we have to put in. We have to give to break this lattice into constituent ions. Yes or no? This is minus because energy is released. This is plus because I am going to use so much of energy to break the lattice into constituent ions. To break the lattice into constituent ions. Understanding? So energy required to separate 1 mole of ionic compound into ionic constituents, into ions, is called lattice energy. Yes, or alternatively, you can define it as, so in that case, when you are defining it in this form, lattice energy will be positive. Or you can define it like that energy must be, if you want to combine all the ionic constituents and form ionic crystal, how much energy is released. That is also lattice energy only. That is also lattice energy, but it will be in negative. Yes. So in this case, it is endothermic. And in this case, it is exothermic. It is exothermic. Yes. If it is endothermic, lattice energy always holds a positive value. If it is exothermic, it always holds a negative value. Are you all understanding? So energy released when the positive and negative ions combine to form a lattice is also lattice energy. It is negative. Or the energy required to break the lattice into constituent ions is also lattice energy. That is also lattice energy. Now, what are the factors which are governing this lattice energy? What are the factors which govern lattice energy? So when we say lattice energy is more, when we say lattice energy is less. Understanding? What are the factors? Okay. First factor. Lattice energy of the ionic compound depends upon following factors. The first factor is size of the ions. Size of the ions. Smaller the size of ion, greater will be the lattice energy. Yes, smaller the size of ions, greater will be the lattice energy. Why? We'll discuss it here only. You can see smaller the ionic radius, what happens? Shorter is the distance. So the lattice energy of the ionic compound, the lattice energy, it is inversely proportional to the distance between the two ions. Distance. So when you take example of sodium chloride, sodium bromide, sodium iodide, you know that as you move down the group, atomic size increases. So distance between the two ions also increases. Can you see here? So as the distance between the two ions increases, to break we need less energy. Yes or no? To break we need less energy. So as distance increases, lattice energy decreases. Yes. So smaller the size of the ions. The distance between the ions in the lattice, the smaller the distance between the ions in the lattice, or larger the distance between the ions in the lattice, weaker is the electrostatic forces holding them together. Yes or no? As distance between the ions increases, yes, the forces which are holding them together decreases. The electrostatic forces decrease. Therefore, I need to put very less energy to break them into constituent ions. So lattice energy will decrease. Yes. So smaller atoms feature smaller interionic distances in the ionic crystals. Therefore, smaller the size of constituent ion, greater will be the lattice energy. Yes. If the size of ion is more, distance will be more. If distance is more, lattice energy will be less. But if the size of ion is less, distance will be less. If distance is less, electrostatic forces will be more. Therefore, lattice energy also will be more. So lattice energy becomes less exothermic and less negative as the size of negative ion increases. You can see here. This indicates weaker attractions between the ions and hence weaker ionic bonding. So lattice energy decreases. Yes. So here you need to put 787 kilojoules to break them into crystals. Minus means what? When they are forming. This is given minus means what? When they are forming. So when they are forming, 787 kilojoules of energy is released here. Okay. Here when they are forming, 751 kilojoules of energy is released. And here 705. If you want to break them, yes, if you want to break these two, they are very small, right? So you need to put 787 kilojoules of energy to break them. So this is the explanation. Lattice energy becomes less exothermic and less negative as the size of negative ions increases. Yes, as the size of negative ions increases. This indicates weaker attraction between the ions and hence weaker bonding. And hence weaker bonding. Therefore, we say smaller the ionic radius, shorter the distance. Shorter the distance, stronger the electrostatic attraction. Stronger the electrostatic attraction, large the lattice energy. So this is the first one. The second one, charge of the ions. Greater the magnitude of charge, greater the interionic attraction, hence higher the lattice energy. So you can see Na plus, Mg plus 2 and Al plus 3. As the charge on the ion increases, atomic size decreases. Sorry, ionic size decreases. As ionic size decreases, electrostatic attraction increases. So when electrostatic attraction increases, both the ions will be held stronger. So when they are held stronger, to break them, we need to put more energy. So greater the charge on the ion, greater is the interionic attraction. And hence higher lattice energy is required. So these are the two conditions. Yes. So for example, in this case, if you consider example of calcium chloride, CaCl2 is greater than potassium chloride, KCl. Yes, because in CaCl2, calcium is having +2, potassium is having +1. Yes, so magnitude of positive charge held by calcium is +2, and which is greater than the magnitude of positive charge held by potassium ion, that is +1. So as a consequence, electrostatic force of attraction are stronger in calcium fluoride than in potassium fluoride. Therefore, lattice energy of calcium chloride is more than lattice energy of potassium chloride. Understood? So this is about the charge. And one more what we discussed, it is about the size. Yes. So these are the two conditions. These are the two factors which affect lattice energy. So this is all about ionic bond and ionic compound. In the next video, we'll discuss about the properties of ionic compound. And before going to the next type, I want to discuss something which I have left behind, that is Lewis dot structure. Yes, if you know Lewis dot structure, next concepts will be understood very easily. So for now, hope you have understood the concepts on ionic bond, factors affecting ionic bond, that is least ionization enthalpy, highest electron gain enthalpy, and lattice energy, high lattice energy. Okay, thank you.